Hi, this is Mrs. Vrobel. This is part 3 of chemical reactions. So for the first video, we looked at how to write a chemical equation, how to balance it. The second one, we looked at how to identify the types of chemical equations. In this third type, or this third segment of the chapter, we want to talk about ionic reactions and how we have formation of a precipitate. So what we're essentially doing is we're taking the individual elements or their ions and we're breaking them down and we're looking for formation of a solid. So if you look at this chemical equation here, we have sodium chloride and it's broken down into the ions and we're adding silver nitrate to it. Now in the product side we get sodium nitrate and silver chloride. Notice that silver chloride is the precipitate. So what you do with these type of equations is you look at what is the product that is solid and you work backwards to figure out what made that solid. So we're going to look at how do we get formation of precipitate, and we're going to isolate the ions that essentially create that. Now we're taking this chemical equation and we're breaking it down into ions. And then when we look at the ions, what essentially we're going to do is we're going to cross off the ions that appear on either side. Now what does that mean? Well, here we have a solid, okay? It's unique on the product side, but notice on the reactant side, sodium and sodium on the product side are essentially the same ion. And we call those spectator ions. What we mean is they don't actually participate in the formation of the solid or the precipitate. Notice that with nitrate, it appears in the product side as well as the reactant side. Notice I did not cross off chlorine and silver because they are the ones that help to make the product, which is silver chloride. So we cancel out sodium and nitrate polyatomic ions because they do not participate in the formation of the solid. So the overall reaction is what is left behind. So silver plus chlorine ions together form silver chloride, which is a solid. Okay, here we go. We could have formation of a gas. Now once again, we're going to take the overall equation, we break it down into individual ions, and then we're going to look at where are the spectator ions. So once again, I'm going to look for where do ions repeat themselves. Notice that I have two sodium ions. They appear on either side. Now here is something different. We have CO3 2-, so that's the ion, but we have CO2 gas. Okay, so I'm not going to cross this off because this is going to be something that we probably need for the formation of a gas. Notice that we have two chlorine ions, so I'm going to cross those out because they appear on either side of the chemical equation. But also I have two hydrogen ions. I'm not going to cross that out because it doesn't appear on the either side of the equation. So notice that sodium and chlorine are considered spectator ions. Therefore, the net reaction is what's left. So we have two hydrogen ions plus CO3 2- gives us carbon dioxide and pure water. Okay, so we could have ionic reactions where we're taking acid and a base and we're forming salt and water. So here we have hydrochloric acid and we're combining it with a base, which is sodium hydroxide. That gives us salt in the water. So the net ionic reaction is essentially the hydrochloric acid split into ions along with sodium hydroxide, and that gives us salt and water. We're going to cancel out because these appear on either side of the equation, and sodium our net ionic reaction is essentially hydrogen ion plus hydroxide ion, giving us water.